Alright, hello there. Alright, really sorry for the late stream. I decided, accidentally, to take a nap about half an hour ago, and I didn't set an alarm. And so I have rushed over here to start the stream. Really sorry for the people who are waiting. But we're gonna get going and see what we get. We're still gonna see what kind of placement we're gonna get in today's challenge. So let's go. It seems like we're going backwards, by the way. Did you notice the map? We were here at the airport. We flew over to here, and it looks like next week we're gonna go backwards. So let's see what happens. My ferry made decent progress towards the island, but the storm came in faster than anyone expected. The ferry needs evasive actions, unfortunately. The navigation computer is malfunctioning, so it is giving circuitous instructions. I think that means we're going in circles. When the captain uses PA system to ask if anyone can help, you volunteer. The navigation instructions by input consists of a sequence of single character actions paired with integer input values. After staring at them for a few minutes, you work out what they probably mean. In directions, L and R means left and right in degrees. And action F means forward in the direction you're currently facing. And we start off facing east, so that's probably important. Only the L and R actions change the direction of that the ship is facing. Okay, so it's like, so if we start off facing east and it says north, the ship is basically strafing northwards. Interesting. So these instructions will be handled as follows. We move forward 9, so we'll be at east 10, north 3. Then we go north 3, we go forward 7, so we're going east again. We turn right 90, and we go forward 11. At the end of these instructions, the ship's Manhattan distance. Yeah, Manhattan distance is, like it says, north plus east. Yeah, if you move 4 one way and 5 up, like 4 right, 5 up, then your Manhattan distance is 9. I figured from, whoa, okay, so apparently so left and right only moves us 90 degrees, which is good. I was trying to get worried we might have to work with like trigonometry and stuff. And yeah, thanks Blue Ghost for that. I didn't get your message when I was reading the thing, but thank you for understanding. Cool. All right. So I'm doing this by hand this time. Okay, so we've got our input. All right, so we've got our input. This seems like a pretty straightforward thing to do. We just say const heading, which is our direction, is at going east. So that's 90. We'll just use bearings here. So north is 0, southwest is 270, and so on. I guess we just go through the instructions one at a time, eh? We don't really have to do much else than that. Const. Oh, I can't use const here, can I? We're gonna move. Let x equals 0, let y equals 0, so that's our current position. Don't think we need anything else, right? So for each input we have, instruction in the input. We're going to switch the first letter of that input, right? If it is, what do we have? We have 7 instructions, right? Case north, south, east, west, left, right, front. So north, that's pretty straightforward, right? I'm gonna do this as well. The direction, the number is going to be. Oh, can you do that? No, you can't. And start substring from 1. Hopefully that works. I'm just gonna pretend it does and see what happens. So y minus equals n in this case. If we're going south, y plus equals n. If we're going east, x plus equals n. If we're going west, x minus equals n. If we go left, then we are saying heading minus equals, left is minus, right? Minus equals n. Well, we're going to equals heading minus n plus 360 mod 360. That's just to keep it within 360. I think that's going to work. This is heading equals heading plus n mod 360. This plus 360 is needed because in JavaScript, I'm fairly sure negative numbers mod, yeah, gives you a negative number. In some programming languages, that will give you 2 instead of -1. But in JavaScript, the way that it works means we have to do that extra plus 360 in there to make sure we're bounding it between 0 and 360 the way we want. And F means we're going to switch heading. This probably should be a switch, but our case. 0, we're going to go y minus equals n. Case 90, we're going to go x plus equals n. Case 180, we're going to go y plus equals n. And case 270, we're going to go x minus equals n. Just check some stuff in here. Just in case we made a mistake somewhere. But I don't think, well, I should not be overly confident. So error, see what happens. I mean, that seems like a reasonable output, right? That seems reasonable. So we're going to add that together. 1319. Cool. All right, let's move on. Before you give the destination to the captor, you realize that the actual meaning of instructions are printed on the back of the instructions the whole time. Almost all the instructions indicate how to move a waypoint which is relative to the ship's position. Action N means move the waypoint north by the given value. Move the waypoint. L means rotate the waypoint around the ship left counterclockwise the given number of degrees. Right means rotate the waypoint that way. Move means move forward the way. But action F means move forward to the waypoint a number of times equal to the given value. The waypoint starts 10 units east and 1 unit north relative to the ship. 10 units east, 1 unit north. 1 unit north is -1, right? Because I'm using north as negative and south is positive. For example, F10 means move the ship towards the waypoint 10 times, a total of 100 units east Ah, but the waypoint stays there. North 3 means move the waypoint north. Okay, so it seems like even if we pass the waypoint, once we say F10, we're saying move 10 times the distance between me and the waypoint in that direction. All right. I kind of don't want to keep this code, but I probably should. Okay, let's see. Where's my first if? Okay. In3 means move the waypoint north by 3, and the ship remains there. F7 means move the ship 7 times towards the waypoint. Total of 70 units. East. Oh, okay. So the waypoint. So it's always waypoint. It's always relative. So we treat the waypoint as like a vector from 0, and we just always do that. It's not like if I move the ship, because I was thinking if we move the ship like 100 units to the east, but the waypoint is still at 10, then suddenly if we say forward 10, now we're moving 900 units to the left. Is what I thought, but that's not the case. F7 moves the ship to the waypoint 7 times, leaving the ship east at east 170, north 338. But this is confusing, right? R90 rotates the waypoint around the ship 90 degrees. That's so confusing. F7 moves the ship to the waypoint 7 times. Total of... But the ship, which way is it? Oh, right. The waypoint is relative to the ship. That is, if the ship moves, the waypoint moves with it. So when it says the waypoint is still whatever. Oh, okay. I get it now. All right, move the waypoint north by that much. Okay, so waypoint moves north by that much, waypoint moves south by that much, waypoint moves east by that much, waypoint moves west by that much. Left and right means rotate the waypoint around the ship. We'll come back to left and right. I might just list out all the possibilities because there's not that many possibilities, right? I might just do something like this. I'm just gonna copy this and be like, if we want to rotate left, right? And there's no L0, but there's L90, there's L180, and there's L270. And then you also have R90, R180, R270, but we don't have R0 either. And I'm presuming, oh crap, we also don't have R360. Cool. Okay, so we don't need this. So if we move left 90, let's do 180. 180 is easiest first, right? If we're facing 5 and 4, we're now at -5 and -4. So wy equals -wy, and wx equals -wx. 90 means our x becomes -y, or y is -x, and y whatever our y is becomes x. Yeah, and y becomes x. I'm just drawing this out in my head and imagining what it looks like if we rotate. And so if we rotate clockwise, oh no, this is, yeah, this is left, right? So anti-clockwise. And if we rotate clockwise 90 degrees, our y becomes negative x, and our x becomes y. Cool. Sometimes listing things out exhaustively is the best. So to rotate right, it is exactly the same thing as rotating left, except the 270 and the 190 cases, and then the 270 and 90 cases are swapped the other way around. You get the exact same thing. And if we go forward, we are heading in the direction of the waypoint 10 times. Oh, by the number of times, right? Okay. So we go y plus equals wy times n, and x plus equals wx times n. I think that is right. That's a really big number. Our heading should not have changed, which is correct. I'm going to go with it. And if it's not, then we'll debug it. I'm fairly comfortable with that answer. Da. Okay. Let's take a look. I'll use this input as a test. It's always good to use that kind of input as a test. Waypoint starts. It did say somewhere that with the waypoint starts 10 and 1, right? Yeah. I feel like I might have just made a mistake with the direction, like direction changing stuff. Yeah, see, that's not the right answer. So I'm just going to print out this stuff at the end of every step just to see what's going on. 100 units east, 10 north, that's correct. I'm also going to print out wx and wy just in case. Don't need to print it out the last time. Just going to make this a bit easier to read. Nah, it's okay. So east, 100 and minus 10, 10 and minus 1 is the unit, is the thing, and then 10 minus 4. The ship remains at 100 minus 10. Here the ship should be at 170, 38, and 10, 4. So it's my rotation. There's something wrong with my rotation. After you rotate, it should be 4 and up. Oh, I know what I did. If I do this, right? How can I do this right after? Oh, that's silly. That's me being silly. I'm gonna see if I can do this in JavaScript. If I can do the double assign. No, I can't. I can probably like if I put square brackets around that, that will probably work, right? So if A is 1 and B is 3, and I do this, okay. So I can do it. So yeah, I have to make sure I do these at the same thing. Yeah, thanks Blue Ghost for that Hint, yeah, exactly that. This one's okay though. Yeah, so I just have to make sure I do the two assignments at the same time. Otherwise, I've overwritten the value already when I, here, right? I've already changed WY. This WY down here is no longer the old WY. I have to make sure those assignments happen at the same time. Ah, that looks better. 286, okay. That looks a lot better. I'm going to put in the actual input. Oops, forgot to turn it off. But that's okay. And our answer should be the final number in there, which is 23720. Let's give that a go. What? Okay, I'm actually quite surprised about that. I am befuddled. Maybe I just need some test input. Just to see what's going on here. North 3, South 5, West 4, East 5. Okay, I'm gonna go left 90, left 90, left 90, left 180, left 270, 3 times. Then we're gonna go right for all these as well. And here we're gonna print out ints so we can see what's going on. Okay, okay. So start at 10 minus 4. If we move north 3, if we start off at 10 minus 1, we move north 3, we're at 10 minus 3. No, we're at 10 minus 4. Move south 5, we're at 10, 1. Move west 4, we're at 6, 1. We move east 5, we're at 11, 1. Cool, okay, if we're at 11 and 1, and we rotate left, we should be now, the waypoint should be at minus 11, 1. That seems right. Yeah. Wait, we're at 11, 1. Then we should be at 1 minus 11. Yeah, that seems right. And then we rotate again, we should be at minus 11, minus 1. Rotate left again, we're at minus 1, 11. Rotate 180. Ah, that didn't work out. That 180, why is it still saying 11? 1. If we're at minus 1, 11, we rotate 180, we should be at 1, 11. If we're at minus 111, we rotate 180 degrees, we should be at one minus 11. Yeah, why doesn't that say 1 minus 11? Oh, heading. Oh, that serves me right for copy pasting. I was switching the wrong value, right? I should be switching the value that's in the instruction, right? In, not my saved heading, which doesn't matter in this part of the problem. So that should be right now, right? -1, 11, we go to 1, -11. Then we go 270, which is the same as right 90. So from 1 minus 11, we go to 11, 1. Then we go to -1, 11. Then we go to, yeah, okay, so that seems correct. And then if we go right from, so we're facing, so we should be going a circle again. Yep, yep, yep. And then here, that's flipping it around. Cool, okay. All right, let's give it a go now. 62434. There we go, we got it. Okay. Interesting little typo. Let's see, what's up with this question today? Other than that, it's a relatively straightforward programming challenge. It's one that I think most people, if you're new to programming, this is one that is quite straightforward to do. Now, I exhaustively wrote out all the possibilities, and when the problem is small enough, yeah, that's again something you can do. Just because it's easier to do that than to try and come up with an algorithm that works for that does different things based on different inputs. Sometimes explicitly listing everything out is the way to go. And so that was today's thing. So I learned a new bit of JavaScript syntax today. Making two different assignments happen at the same time. And that lets us swap values, which means you can also do this sort of thing to swap values around, right, in JavaScript now. Which classically you would have to do the 3 statement where you go t equals a equals b equals t. And I'm sure internally it does that anyway. But yeah, that's really cool. Thanks for joining me today. Really sorry about the late stream. And I will see you again tomorrow. Thanks for joining.